Mention's theorem states that the circumcenter of a triangle formed by connecting two vertices and the incenter of an original triangle is a point on the circumcircle of the original triangle. In this diagram, triangle ABC is the original triangle, and the triangle formed by connecting two vertices and the incenter of the original triangle is triangle IBC. Point M is a circumcenter of a triangle IBC. With Mention's theorem, we can prove that segments MI, MB, and MC are congruent. First, angle MBC and angle MAC share arc CM as an intercepted arc. Therefore, angles MBC and MAC are congruent according to the inscribed angle theorem. The segment connecting an incenter and one vertex on the triangle bisects the angle on that vertex. Using this property of the incenter, we can determine that segment BI bisects angle ABD. Therefore, angle ABI is congruent to angle IBD. Likewise, using the property of incenter, we can find out that segment AI bisects angle BAC, making angles MAC and MAB congruent. In a triangle, the sum of the two interior angles is equal to the exterior angle of the remaining interior angle. This is called the exterior angle theorem. The sum of angles MAB and ABI is angle MIB. Applying this theorem to a triangle AIB, angle MBI is equal to the sum of the angles MBC and IBC. We already know that angle MBC and angle MAB are congruent, and angle IBC and angle ABI are congruent. Therefore, angle MBI is also congruent to angle MIB, since triangle MBI has two congruent angles. Segments MB and MI are congruent using the isosceles angle theorem. We can do the exactly same thing on the triangle MIC. Angle MAB and angle MCB shares arc MB as intercepted arc, making them congruent. Property of incenter makes angles ACI and ICD congruent, and angles MAB and IAC congruent. Angle MIC is equal to the sum of angles IAC and ACI because of the exterior angle theorem. With angle addition and substitution, we can find out that angle MCI and angle MIC are congruent, making triangle MIC isosceles and segments MI and MC congruent. Since MB is congruent to MI and MI is congruent to MC, three segments MB, MI, and MC are congruent. Circumcenter means that segments between the circumcenter and all three vertices are equidistant, making point M circumcenter of triangle BIC. One of the possible applications of Mention's theorem is Euler's triangle theorem. Euler's triangle theorem states the relationship between the distance between the incenter and the circumcenter and the radii of the circumcircle and incircle. In this situation, Mention's theorem is used to prove segments BM and IM are congruent, which is needed to connect these two equations that are proved by the power theorem and triangle similarity. Uppercase R stands for the radius of the circumcircle, lowercase r stands for the radius of the incircle, and the d is the distance between the incenter and circumcenter.